Um, Good evening, participants. Good evening, teachers, educators. Thank you for being here with us today. Let's just wait for another minute so all the participants can join and then we'll begin.
Good evening, everybody. A warm welcome to another exciting webinar. Over the misconception series, we have explored common misconceptions across subjects like English, maths, and science. We are eager for an interactive and engaging session ahead as we learn and grow together. Looking forward to all of your active participation. Before we begin with our presentation, here are some points for all of us. Since this is a webinar, the participants will not be able to unmute themselves. However, we have a Q&A section where you can put in your doubts, share new ideas, and engage with the presenters. At the end of the session, we have a feedback form. Please make sure you fill the feedback form for us. Let me begin by introducing myself and my colleague here. My name is Aruna and I work as a senior academic consultant at EI. And Purva is joining with me. She works as the educational specialist at EI. EI is a 25-year-old company with a vision to create a world where every student learns with deep understanding. Our vision stands on three key pillars: pedagogical research, leveraging technology to scale, and the science of learning. Together, these elements guide our mission to transform learning experience for students. Let's now look at the objectives of today's webinar. First, we will start by understanding what misconceptions in science really are. It's common for students to develop ideas based on what they observe, but these ideas can sometimes be inaccurate. We will see how these misconceptions form in a student's mind. Next, we will look at examples of misconception, specifically the ones we have seen in ASSET. These are real world instances where students' responses reflect common misunderstandings. This part will give us insight into the kinds of misconceptions we are dealing with across different grades and subjects. Finally, the most important part: how do we remediate these misconceptions? Here we will explore strategies that you can apply in the classroom to help students break free from their misunderstandings and build accurate scientific knowledge. As you all know, ASSET focus on two essential aspects of assessing students' performance. First, the diagnostics and the benchmarking. Let's talk about diagnostics. The image of the microscope that you see symbolizes a deep focus look into each student's performance. Diagnostics allow us to get an in-depth view of how individual students are understanding or misunderstanding specific concepts. This helps identify gaps in knowledge or misconceptions at a detailed level so we can provide targeted interventions for improvement. Next is the benchmarking. Benchmarking offers an overall perspective of how students are performing on the large scale. This could be across entire class, school, or even compared to national standards. It helps us see where students stand relative to a big picture, allowing us to track progress and set goals for overall improvement. Together, these tools help educators to gain both a comprehensive view of students' learning, providing the insights necessary to support effective teaching and meaningful student progress. Let's also look at the three big parts of asset. Right? As educators, we understand that true learning isn't just about memorizing facts. It's about developing critical thinking and problem solving. And this is where asset skill-based benchmarking test comes in. Asset focus on assessing students' conceptual understanding rather than rote knowledge. By presenting real-world application questions, it helps identify gaps and misconceptions the students often carry. The diagnostic analysis shows us where students are facing difficulties, whether in foundational topics or advanced concepts, allowing teachers to target these areas more effectively. This enhances teacher effectiveness by building tailored lesson plans and more focus on remediation. In the end, it's not just about teaching harder, it's about teaching smarter. By leveraging assets data driven approach, educators can now ensure that learning is truly understood, paving the way for a long term academic success. Before all of that, let's start by understanding what are misconceptions and how do they occur. Can all of you take a moment and go to the Q&A session and type in your definition for misconception? Okay, waiting for some answers. What do you think is a misconception? Okay, some are saying that misconceptions are faulty understandings, okay? Wrong knowledge, okay? Conclusions that's wrong because it's based on faulty thinking or facts that are wrong. Great. Thank you so much for all of those answers, right? And all of you are right. A misconception is a faulty or mistaken belief that students hold about a concept. It's not just lack of knowledge. Students actually believe something is incorrect to be correct one, right? Importantly, misconceptions can persist even after teaching. Even though we give accurate information, students may still hold on earlier beliefs because they are deeply rooted in prior knowledge and everyday experiences. Misconceptions can be conceptual or procedural. They are normal part of the learning process. In fact, they actually show that students are making sense of what they are learning. However, if not addressed, misconceptions hinder further learning, and many students in a class can share the same misconception. The good news and the great news for all of us as educators is that misconceptions can be remediated with a targeted approach, but only when first we identify them. Purva, let's now deep dive into what science entails as a subject.
All right. Thank you, Aruna. So, I'm sure all of us already know what science is because we're all science educators here. But let's try to understand it a little more and with some more detail. So, firstly, science is an empirical field of study. Now, what this means is that knowledge in science develops through observations, through experimentations, and that's why whatever knowledge we get in science, it's very objective and it's very logical. It's not open to interpretation. For example, if I drop an object, right? It's no matter where I am in the world, if I'm in India, if I'm in the United States, or if I'm anywhere, I know that this rock will fall to the ground because of the force of gravity, right? So that's why this is what makes science very objective and very logical. um, and finally the third thing is that science is a process. So it's a process wherein knowledge is continuously developed, right? So something that was true, let's say 100 years ago, it may or may not be true today. It could be proven wrong using observations, using some kind of experimentation. So, if one wants to build mastery in science, it's very important not just to understand science and the concepts, but also to build skills that will help us observe, that will help us experiment and analyze it better. So, yes, academic testing in science involves not only testing the concepts of science, but also skills that help us experiment and observe, and sometimes even hypothesize, right? So, what do we test in asset? Obviously, the one of the most important pillars is concepts, right? So we are testing concepts like life sciences, where we have animals, plants, natural resources, phenomena, etc. We have physical sciences, where we're testing light and optics, heat, energy, all of these things. But we also interestingly have scientific literacy, where we are seeing if students are able to do estimation, if they're able to understand what kind of equipment they should probably use for an experiment, what are certain scientific terminologies appropriate for their grade level, of course. So these are some of the concepts we're testing, but that's not the only pillar. We also test skills such as knowledge of basic scientific facts, conceptual understanding. Are they able to do reasoning? Are they able to do analysis? Right? And also something called original thinking. So are they able to think in their own way, like, different from what they probably read in the textbook or maybe heard in the class during the session, right? So are they able to have their own way of thinking? So original thinking again is a very important aspect here. So students should not only learn concepts, but they should also be able to gain skills. And it's very, I mean, this is also actually what 21st century skills are talking about, right? So there are multiple groups under which we have 21st century skills. Some of them are critical thinking, creativity, collaboration, communication. There's also information literacy, right? So these are some of the skills, 21st century skills, where we must try to have our students inculcate. And I would like to draw your attention to this table on the right, teachers. So this is actually an example of how educators in USA and Canada are very methodically and in a very focused manner, they're mapping their science teaching and learning to the 21st century skills, right? So basically what's happening over here is that the students have been given an activity of creating some sort of device. Now, while that's the activity, what teachers are doing at the back end, we can say they're making sure that when the kids are doing certain actions, they are displaying certain 21st century skills. So by mapping it out like this, teachers are able to ensure that during their lesson, during their class, they are ensuring that students are actually inculcating these habits. So by doing certain things, they're getting critical thinking skills. By doing certain things, they're able to collaborate with their partners. By doing a certain sort of things, they're able to communicate better, right? So this kind of mapping will, like mapping of skills to the science lesson is, of course, very beneficial, and it'll help with holistic student growth. So, yeah.
Yeah, thank you so much for sharing that, Purva. That was really interesting to see some, exceptional practices that's been happening across the world, right? Purva, I have one more question for you. Since you're part of the team that actually makes these questions, right, these assessment questions, can you help us understand what are misconceptions in science? I also want to know, are they similar or different from the other subjects?
Okay. Yeah, so that's a fair question. So from all your responses, we know that misconceptions are an incorrect idea. They're a flawed understanding of a certain concept, right? But why misconceptions exist in science is going to be a little different from why they exist in other subjects. Let's say in English, for example, misconceptions could arise because they don't speak that language at home, right? It's
Hmm.
not their first language. And that's why they make incorrect sentence structures and so on. And in math, we can say that, I mean, some one of the reasons could be that as a subject itself, it's a little abstract, right? So
Right.
that's why misconceptions could arise there. But that's not exactly the case with science, because science is
Hmm.
all around us. We feel,
Right.
we see, we hear, we experience science almost on a moment to moment basis. And
Hmm.
despite that, misconceptions exist, right?
Hmm.
So there could be multiple reasons for this, but one of the major and the most obvious reasons is, while I am experiencing science around me, I may interpret it differently from a person sitting next to me. So while we're both experiencing the same thing, our interpretation of the experience could be different.
Hmm.
Let's talk about this in a little more detail. Um, Sometimes misconceptions arise in science simply because of the language of science. Like we tend to interchange between mass and weight, right? I'm sure nobody would have gone to a gym and said, okay, let's lift some mass. While technically we should be saying mass, but we end up calling it weight. And when we go back to our physics class, we realize, okay, no, this is not the same thing. Weight is actually something different. So that's one of the reasons why there are misconceptions, simply because of the language of science. Again, this is a very common example where the student is actually carrying a lot of load. So technically, they are doing a lot of work, but according to science, this person is doing no work, right? So yeah, so I mean, I think just language of science can be confusing sometimes. Then there's oversimplification, where we say things like electricity flows like a
Hmm.
river, or in ray diagrams, we're showing an object as an arrow which is upward or
Yeah.
downward. So this becomes very complicated for the student to understand because of the level of oversimplification that's there, right? And this was something I struggled with a lot back in school. So evaporation and vaporize, they sound so similar, and that just made me feel like, yeah, they're just two similar words and they mean the same thing, but actually there's a very, like, a drastic difference between the two. So
Mm.
unclear words, phrasing, similar sounding words, um yeah, all of these things could make misconceptions arise in science. But let's actually take a look at what research around us is saying. Like, there are researchers around the world who've tried to figure out why there are misconceptions in science, and these are a couple of things that they have said about it. So what happens is, when we have an experience, our mind starts generating a preliminary theory about it. For example, I see a feather fall and I also see a stone fall, right?
Mm.
And I notice that the feather is falling slowly and the stone is falling at a much faster speed, right? And I've probably seen this with a lot of other things also. So I generate a theory about
Mm.
this in my head that, okay, light objects fall slowly, heavy objects fall fast, because that's what I've seen. And the
Right.
next day I go to class and then I learn that no, that's not how it works. Mass is not going to decide how fast or slow an object falls, right? And at this point I become very, like, my theory that I generated in my head, that's being challenged. So I'm finding it
Mm.
very hard to believe this, because I have seen this, I have seen it happen, I have experienced it, right? So every time there's an opposing idea to what I have strongly believed, my mind will tend to discard that opposing idea, and that's where it becomes difficult to create the correct conceptual understanding. And this is what researchers are saying about why students are having misconceptions in science.
Right. Right.
So, yeah, I mean, Aruna, would you like to take us through some three broad categories of misconceptions?
Yeah, sure. Purva would like you to also jump in wherever there's coming. So, the first three broad main categories of misconceptions. One, of course, the conceptual misconceptions. You can see the picture here. Purva, would you like to explain
Yeah.
us about this question
Yes.
here?
So I think we learn in class that by looking at the leaf, at the venation, we can find out what type of root
Hmm.
um, the plant will have and what type of seed also will, whether it'll be a monocot or a dicot seed, right? So
Hmm.
this is a concept that we learn in class, and if a student is not getting this concept right, you will
Hmm.
see results something like this, right?
Yeah.
And if you look at the data, it's I mean, they're almost in the same range, right? It's between
Hmm. Hmm.
19 to 31. It's almost in the same range, and that shows that students are actually very confused about,
Confused.
right?
Right.
Because it's all in the same range. So that's the first category. Then there's the second category, which is preconceived notions. So if you look
Hmm.
at this question, Jaleel has three materials: candle wax, water, and an iron bar.
Iron bar.
Which of these materials is capable of existing in all states? Now,
Hmm.
teachers, I would request you all to participate. Please tell us what you think students might have answered. Most students might have answered. Don't share the correct answer. Just think about what students would probably have said. Let's take 30 seconds. And I really request all of you to participate so this can be a more interactive session.
Yeah. This is one of the interesting question. Teachers, please put your responses in the Q&A.
Okay, Jimmy,
Only
sir is saying
water.
that A, most students would have said A. Sharbari ma'am is saying that most students might have said C. Arun sir is saying C. Okay, lots of A's and C's. Okay, okay, that's great. Okay, thank you, teachers. So I mean, I think you were bang on correct answers from you. Most students have actually picked A and C. And
Yeah.
again, if we think about why this is, it's because of their preconceived notion, right?
Hmm.
Maybe because they have seen water in three different states. And maybe some of them would have also seen wax, melting, and then it's also solid. And sometimes they would have also seen some vapors. So they've believed this because they have seen it. So they've generated a preconceived idea
Yeah.
about this. But technically, that's not true, right?
Hmm.
Any object anything that is matter can exist in three different states. Of course, having a liquid state of iron would require very high temperature, but it's not impossible. In fact, liquid
Correct.
iron is used for different processes like thermite reaction and all of these things, right? Um, so yes, preconceived notions becomes one category of misconceptions. And then there's vernacular misconception. So if we look at this question, this is a grade 10 question. Which of the following Venn diagrams best represents the relationship between the cellular components and or the processes found in green fungi and green leaves? So if we look at the data we've got, only 16% of the students were able to understand that the only thing common between fungi and green leaves is that cell wall that they have.
Hmm.
But a large majority of students have said option C. And this clearly comes from the wording, right? The word green, if there's green something, the kids just tend to believe that green would mean there is chlorophyll, chlorophyll would mean there's photosynthesis. So if
Photosynthesis.
there's green fungi, they should also be able to perform photosynthesis. And again, this comes from a lot of the wording that we see in textbook also, that green plants photosynthesize, green. So every time they think of green, they're probably thinking of photosynthesis. So that could have led to this misconception. So these are all questions that were actually used in the winter round, and this is the data we've got from those questions.
Right.
So there are again some more categories. I'll just quickly take you through these. Teleology means explaining natural phenomena with a purpose or with an intention. Like saying birds want to fly, so they have wings.
Wings.
Or
Hmm.
giraffes want to reach the tall trees, and that's why they have a long neck. So when
Hmm.
we're saying that this is the purpose of this phenomena, that could lead to some kind of
Misconceptions.
misconception,
Hmm.
because birds don't have wings because they want to fly.
Hmm.
Birds have wings and so they can fly. That
Right. It's
would
the
be a
other way
better,
around.
yeah,
Hmm.
that would have
Hmm.
been a better way of explaining the same
Hmm.
idea. Then there's anthropomorphism. This means attributing human characteristics to non-human entities, like saying the atom wants to become stable, so it gains or loses an electron. Or
Hmm.
like, things like the moon is following me. You're
Yeah.
giving a human-like feature to something that is not human.
Like electricity is flowing,
Yeah.
like that also comes,
Things
right?
like
Yeah.
that, yeah. Yes. And again, overgeneralization. Sometimes in the flow of the class, we tend to say things like all metals conduct heat or
Hmm.
all metals conduct electricity. But that
Hmm.
then when they go to a higher class or maybe in the next class, they realize, oh, no, that there are some misconceptions in this, right?
Hmm.
So when it's time to when it's time to know, learn the misconceptions, they aren't able to register it because they believe that okay, no, all metals conduct electricity. So that
Hmm.
again becomes a little confusing for them, and that could lead to certain misconceptions. Yeah.
Right, right. Pruva, this is really interesting, and thank you so much for picking up a lot of real life examples. It was so much relatable, to connect to those and then try to understand this concept, right? I was also thinking, Purva, like I interact a lot with teachers in schools, right? So during my interactions, a lot of teachers and school leaders have asked me about how are asset questions created? Like what are things you keep in mind while creating asset questions, right? Can you please take us through that?
Yeah, sure. So one thing I would want everybody to know about is that asset is board agnostic. So we cater to all boards, yet we cater to no board, because we do not follow a particular board or a particular textbook while we're making our questions. And what we actually do follow, what our guiding light is, that's the NCF, which is the National Curriculum Framework. So the NCF tells us about the skills and the essential concepts that a student should know by a certain grade level, right?
Hmm.
So, for example, this is a grade 6 question. So, uh, by this grade, they should know that, okay, there are some different sources of water. Um, and if we take a look at this question, Geo wanted to know from where our body gets the water it needs. His friends gave him the following answers. Shafiq said, from the liquids we drink. Rafi said, from the food we eat. Arjuna said, from the water that we drink. So, who is correct? Right? So, this is the question, and now we know, of course, that answer is D. All, I mean, because any food item that we consume that will have some amount of water. But
Hmm.
how do we build the other distractors? So building, so actually a lot of my time while making asset questions goes not only on creating the question, but a lot of it goes on making the correct set of distractors, because I
Right.
want to make sure that each distractor is leading me to some kind of misconception. So if students pick
Right.
that, there is a chance that they have this misconception. So, for
Hmm.
example, why did we make this option A? So, students here who are selecting this option probably think that water is the only, only the drinking water is going to provide our body with water. That's the only source, right?
Hmm.
Then B could be because they're simply guessing that, it could be food and water. And if they selected option C, that it's only Shafiq and Archana, then students think that any food that has liquid, that liquid will give water inside the body. So that could be another misconception they have.
Right.
So
Right.
so we're building distractors or incorrect answers,
Hmm.
and all of this helps us lead to certain misconceptions, and all of this is made by looking at the common wrong answers from the past years and past data that we have, or student interactions that we have conducted, and also research studies that have said something similar, and based on that then we um, get into creating these questions. So,
Yeah.
and then we get data like this. So data like this, we get to know that, okay, most students have such misconceptions, and then we share it with teachers. So then teachers can then go back and remediate these in their classes.
Yeah.
Yeah. So let's now dive into the main exciting activity for today, which is looking at questions that were asked in the winter round of ASET in 2025, and some of the questions that had very deep-rooted misconceptions that we found. So we'll discuss some of these questions. We'll also look at data for these questions. And yeah. So the first question, the skill will be mentioned at the top, and also the class will be mentioned on the right side. So yes, this is the first question. Dinesh is standing very still at one point. He notices that his friend Jannat is always standing at a distance of 5 meters away from him. Based on what Dinesh observes, which of the following statements could be true? Jannat is at rest, Jannat is moving in a circle, or Jannat is moving to and fro. So, which of these options is correct? A, B, C, the different combinations are given. Again, teachers, I would like you to share what you think most students would have answered, and then we look at the data. Let's take a quick 20 to 30 seconds to look at this.
Answers are already pouring in.
C, according to students, okay. Kavya ma'am is saying that it could be C. Okay, Rabia ma'am is saying it could, most students might have said B. Okay, let's have some more answers, teachers. Okay, Sharbari ma'am is saying B. Great. Okay, lots of answers pouring in, B's and A's. Okay, all right. So if we look at the actual data, it's showing that most students have actually picked option A, and very few students have picked option C. So the objective of this question is to see if students can understand motion and distance, specifically if they're able to recognize that constant distance from a point. What does that mean? Does it mean that the person is at rest? Does it mean that they're moving along a circle, or could it be to and fro, right? So based on the responses, we can clearly see there are some misconceptions. First misconception is that constant distance equates to no motion, right? So students think that if something is staying at the same place, um, and then that observer, from the observer, then that thing might be at rest, and they are ignoring that motion could also be circular. And another thing is that students might think that arc motion changes the radius, right? So they might not realize that the to and fro motion is actually a part of a circle, right? And they probably think that in this arc, the radius is increasing as it goes from the mean to the extreme points. So maybe they're not able to visualize it correctly. So some things that could help with this is, I'm sure most of you might have the same idea. Just put a point, like a pin, and tie a rope to it and take it around and ask students to measure the length of the rope at each point, and they will realize that even in circular motion, the distance is still the same. So you can come up with many innovative activities like this to remediate this misconception. And once they see it happen live, we you can always go back to that research theory which says that when they see it happen, they build the theory. So if we show them the correct thing, they could actually build the theory and remediate this misconception. Let's now look at this question. Again, grade 7 question. Um, so given below is a chart that shows how long some animals live. The numbers in the chart indicate the number of years, and now they're asking what do the animals that are in gray, what is that representing? So here students have to apply some skills, right? Of not only being able to classify, but also a little bit of data analysis of sorts, right? So they have to go through this data, see what's different, what's happening here, and based on that, provide an answer. So the objective of this question was to see if students are able to classify animals based on their biological characteristics. So when we look at the data, we can see that there is a clear misconception where they are not able to identify the common classifying features in all the animals, the gray animals, that is that they're mammals. So a lot of students are actually thinking that only mammals breathe air, right? So, and that also could be because they've only seen mammals breathe air, and that could lead to this misconception. So only 20% of the students have been able to provide the correct answer. um, so yes, that's another thing. um, then let's look at this question. It's again similar to the previous question. I'm jumping to grade 10 again to show how the skill of classification and comparison or understanding what mammals are. That's not there only in grade 7, but we're also seeing a similar misconception in grade 10. So again, in some species of fish, the young ones develop inside the mother's body and they are born live. Still, these fishes are not classified as mammals. What could be the reason? So there are some options provided, and we see the same misconception here also. Students are not able to identify that mammals are those um, organisms which are able to give birth to their young ones, and they are able to not only give birth to their young ones, but they're able to feed their young ones with milk, right? So they're not able to identify this. And yeah, I'm sorry, I think the wrong answer is marked. It's option A is not the correct answer. um, the correct answer would yeah, so I'm sorry about the wrong green marking. Yeah. Now let's look at the next question. This is again a grade 7 question. Aman has the following setup containing a torch and a screen. He places these balls shown at different times between the torch and the screen and measures the size of the shadow they cast. At what distance from the torch should he place the balls so that they are likely to cast shadows of the same size on the screen? So here the objective of this question is to see if students are able to understand how shadows are created, and if they're able to understand that if there's a larger object, it needs to be placed farther from the torch to produce a shadow of the same size as that of a smaller object. So because ball X is bigger in size than ball Y, it should be placed farther away from the light source, and ball Y, which is the smaller one, that should be probably placed a little closer. So based on that idea, they have to pick the correct answer. But as we can see, there is, I mean, most students have picked the correct answer, yet a significant number, 30% of them, have picked option B, which is the exact reverse, right? So that could be, again, something we can go back to class and remediate and talk to them about this. And a very simple experiment, so we could actually even conduct this in class. Then here there's a question about magnets. And here the objective of this question is to see if students understand the properties of a magnet. So there is a bar magnet that is suspended, and we can see the orientation of this magnet. So when it is freely suspended, Q is in a certain direction, P is in a certain direction. So students should be able to relate this to when a magnet is suspended, it automatically gets arranged in the north-south position. So that should give them an idea that, okay, Q is the north pole, P is the south pole. And then we're saying we're cutting this magnet into two halves. So this again should take them back to the idea, even if you cut it, they again get divided into north, south, all of that happens. So again, when we look at the data, only 27% of students got the correct answer, which is option C. And 42% of them have picked option B. So if you see something interesting here, option A, C, and D show Q is the North Pole. And despite that, students have picked B, which is the only option where Q is the South Pole. So and one more very interesting point that I would like to share with you is this question got a positive PBC for the wrong answer. What that means is that even students who have done well in the rest of the paper, they've actually scored well in their asset paper. They have marked this as a wrong answer. That they've picked option B for this. So not only are weak students struggling with this question, but even students who are actually doing well in the other questions, they have made mistake in this question. So yes, there's another magnet question where Riju has arranged a horseshoe magnet and three bar magnets on a wooden table. And based on this, which of the following arrangements can these be placed together? So the idea is to see if they understand that like poles repel and unlike poles attract, right? So it seems like a simple question, but when we look at the data, a very close majority of students have picked option A also, right? And a lot of them have also picked option C. So there is some misconception here also. And again, this question also has a positive BBC for the wrong answer, which means students who've done well in the rest of the paper, they have also picked the wrong answer here. And then we have a question from natural resources and phenomena. So here, this is something even I used to be very confused with sea breeze and land breeze. So here the question is saying that John is flying a kite during summer holidays at the seaside, and the picture is showing the pictures below are showing him fly his kite on the beach at certain times of the day. So midday, midnight, and midday. So which of these are actually correct? So here this question is designed to see if students have an understanding of sea breeze and land breeze, right? And during the day we know that seaside the land is going to heat up faster than the water, and that's why the hot air over the land rises, and the cool air from the sea moves in to replace this, and that's why there's a sea breeze. So based on this, they should be able to apply that logic that in during the day this is what happens, and at night the reverse happens, which is the air goes from the land to the sea, so that's land breeze. So based on that, they should be able to answer this. But again, most students have picked option D. So there is a misconception clearly in this. And again, this question has a positive BBC. So all students are struggling with this question, even the ones who have done well. This is an interesting question. This is for ninth standard. Um, so Anita uses a solution X in an experiment and finds that it conducts electricity well. She then dips red litmus paper and blue litmus paper in the solution X. Now, this is something I've also observed students have a misconception about when I've gone on visits and interacted with them. So, students think that if a solution is conducting electricity, it should be an acid or it could be a base. Only acids and bases conduct electricity. So, if we look at the data, it's quite shocking. Only 21% of the students have understood that no, you can't tell whether this is, we cannot come to any conclusion based on the information that's provided, because this could be uh, a salt solution also, which is neutral. So that idea is not they're not able to understand this properly, that it's not that only acids and bases can conduct electricity. Any ionic solution, including like a salt solution which is neutral, that could also conduct electricity. So this needs to be remediated. um, then we have another misconception here in physics about friction, right? So the very simple question: in which of the following is friction acting? So we have seen examples in our books about friction on the road on a solid surface, or when there's a ball rolling, so it comes to a rest after a certain point because friction. So we've seen P and Q very commonly in our textbooks, but R, which is on a hovercraft moving on a layer of air above water. So it's not touching the water, it's in air. So here students have to identify which of these is actually having friction. And the question is designed to see if students can identify that okay, each of these actually have there is frictional force acting in each of these, but maybe they have not seen the idea of air being a source of friction, and that's why we see 48%, nearly 50% of the students have picked option C, which is only P and Q, because there's a solid surface. So again, that's a strong misconception. All right. Now, this is a question about mirrors, and it's trying to test if students have the knowledge of how images are formed in a mirror. Um, so there are two mirrors, M1 and M2. The shaded sides are shown clearly. They are placed at an angle, and there is an object O which is placed in front of mirror M1. So which virtual images will be formed in this arrangement? That's the question. So most students will understand that object O will create a virtual image here. But if we look at the data, a lot of them think that it could also, I mean, if you look at option C, image 1 and 2, so they think that this image which is created here could act as an object and then make this image over here. So the image 1 becomes an object which passes the rays of light come here, and then an image is created here. So 22% of students have actually selected um, the option C. And again, the neither image one or two is selected by 37, the majority of students. So that's again a clear misconception that they have. Another mirror related question. This is a very interesting one. Um, a very small bulb is placed at point X. So there's a point X shown here, and rays of light from the bulb falling on the mirror are not shown. But which of these rays could have reflected, could be a reflected ray of light coming from the bulb? So they have to think about the positioning of this, um, the bulb, and then they have to understand, okay, which of these PQRS could actually be the reflected ray. So simple thing here, they have to just apply the law of reflection. Angle of incidence equals to angle of reflection. So they have to apply that and try to come to the answer. But when we look at it, it's quite shocking because only 18% of the students were able to get the correct answer. And a vast majority of them have actually selected option B with, and here, I mean, it could also be because they did not see the arrows properly, right? And they've just selected this because it looks like what they've seen in their textbooks, right? The typical equal angle sort of thing. Um, so how do we remediate this? Like, and I completely understand that this could be very difficult to remediate because we are just trying to explain this concept with arrows, and we're not actually using a protractor and measuring the angle of reflection. So I'd like to show you one simulator that I use very often. I hope you're able to see my screen. So what I do here is I pick a mirror, and I use a circular arc mirror, and I can create this mirror like this, and I choose the whether I want it to be concave or convex. For now, let's just have it as a concave mirror, right? And then I am going to add a light source. I'm just going to take a single ray for simplicity right now, and I use this. So now what this does is you could show this to your students and see how when you're changing the angle of incidence, how the angle of reflection is changing. So when I bring it here, or when I change the way the incident ray is coming, how does the reflected ray change? So this could be very useful. It could help students understand this concept better. And not only, I mean, you could use a, instead of single ray of light, you could use a beam of light with parallel rays and all of that also. So this is quite helpful. Aruna will share this with you all in the chat box, so you could also take this back to your classes. I hope this helps. Moving on. The next question is about uh, it's from the concept of heat. Again for class 9, Janet took four empty cups PQR and S of the same size, but they're made of different materials. And she placed an identical ice cube in each of these, and she covered them, and she noted the time taken for each of these cubes to melt completely. And you can see the time. So P is the least, S is the highest. Next day, she poured 150 ml of hot tea in each of these cups, and based on this result, which of these would have cooled down the fastest? So students know that for ice to melt, it's taking so much time. How much time will it take for hot tea to become cold? So they have understood the idea of ice melting. So the temperature, matlab, from cold ice becoming normal temperature water, right? So they've understood that. Now they have to reverse it. They have to go from hot to cold. So, I mean, technically they should understand that if a container is a good conductor of heat, it'll work both ways. But when we look at the data, yes, most of the students have picked option A, but there is a big majority, 35% of students have picked option S. So they're thinking the reverse, right? The cup in which ice melted fast conducted heat most readily. So ideally the same cup will also lose heat the fastest, but students are reversing it because they're thinking now it's not it's not cold to hot, this time it's hot to cold, so they've picked the other extreme without applying the correct logic. So this is quite an interesting misconception we can see. Here's another question where the objective was to see if students are able to understand that same weight does not only depend on size. Okay, just because an object looks bigger or smaller than another object, it does not necessarily mean that it is heavier or lighter. So you can see that we've said that there are a few balls hung from sticks shown below, and the sticks are perfectly horizontal. So we're saying that this is perfectly horizontal. So in which of these cases is the ball weighing the same? So let's look at the results. Students who are selecting option A, they are thinking that, because these two balls are of the same size, and the joining point is also right in the middle, this linkage point, so this has to be the only correct answer, and they've just decided that option this is the only correct one. When we look at students who've picked option B, which is P and Q, so they have said that okay, this is also of the same size, and again this is also of the same size in Q, so that's why P and Q must be having the balls with same weight. So students are not, they're missing the point that in Q it is not placed at the equal, it's not placed at the center, so they're not, these two balls are not equidistant from the center. So that's another thing. But yeah, only 20% of students have understood that it's P and R because it is placed at the center. The linkage point is at the center. So both balls are equidistant from the center. So they've not understood this point. And most of them might have also thought that, okay, because this is appearing smaller than the bigger ball, so it cannot be of the same weight. So that's a misconception. Simple, yet we're able to understand that this is a deep rooted misconception that students have. This is an interesting one again. I'm sure a lot of students find the idea of pressure being equal to force by area, right? So the interrelationship between area of contact and pressure, that becomes very exciting when we look at the examples. So we've tried to create a similar idea here where we are saying that okay, there is a clay block and we've put two glass blocks on top of them, and which clay block is more compressed? Okay, so which of the statements is true? So here, if we look at the data, most students have said clay block 2 will be compressed more as pressure exerted on it is more. And how did they come to this conclusion? It could be that they saw that in this first glass block, a larger surface area of the glass block is on top of the clay block, whereas in this, a lesser surface area is on top of the clay block. But what they've missed is area of contact. So area of contact in both cases is the same. In this clay block one also, only so much of the clay block is in contact with the glass block, And in this one also, only so much of it is in contact with the glass block. So area of contact is actually the same in both of them, but they've just looked at the appearance of the bottom, the glass block, and they've decided that. But that's not true because the area of contact is still the same. So the answer is actually that both clays will be equally compressed. Um, okay, here's another question on sound. This is for class 10 students. Um, so shown in the figure is a speaker from which sound is emitted continuously. A dust particle is marked here, P, and which of the following describes the motion of the particle. Now, this is something that is taught in class about, like, how particles are not moving essentially, but they're only vibrating, and that's how a sound wave is propagated. It is propagated because of the to and fro motion or the vibration motion of the particles, and not because the particles itself are moving, or they are not, like, in a wave of sorts. But when we look at the data, we see that a significant portion of students have picked options C and D, where they think that the particle keeps either moving towards the right and the wave like motion, because this is something they've seen in the textbook, that the wave. So they've just applied that connection and they've picked it. Um, so yeah, but how do we fix this, right? Because this is not, how do we show that particles are like this? But thanks to modern technology, we have a lot of interactives nowadays. So if we look at this, I'm just going to close basic motion. So you see here, going to increase the frequency. So now you can tell your students here, see, if you look at each particle, it's just moving about its position. It's not going to the next place. It's not moving ahead or to the left or to the right. It's just doing a to and fro motion. So this would probably help them in understanding that, this is how waves are being propagated. I hope you're able to see this. We will share this link with you as well. So you can also show this to your students. So when they see this, I'm sure this will help them understand the idea a lot better. Yes. This is actually a very simple question. It's direct recollection, but we still see that there are some misconceptions here. So again, I would like to reiterate that having questions that are based on recollection is not a bad thing. It's good to have, there should be a good balance of mechanical understanding and application based questions. But the way we put our mechanical questions also, we could be a little, um, uh, we could put a little bit of thought into it, because they could also give us some serious misconceptions. So here we're asking students that which of the following particles, P, Q, or R, essentially, which is the electron, proton, or electron, neutron, or proton, which of these, when added to the carbon atom, would still allow the product to form? So, whose addition is not going to affect this reaction? That's what the question is testing. And while we know that the answer is neutron, most students have picked that, but yet there's a very close percentage of students, 28% of them have picked option A, which is electron. So they think, because again, we speak about addition of electrons, removal of electrons, but maybe they've not registered the fact that addition and removal of electrons is not, this could lead to a different product here, or it could affect the carbon atoms. Yeah, so again, this is a misconception. Um, and finally, we have another question here about the number of nuclei. So here we are asking students which of the following bar graphs correctly represents the number of nuclei found in each type of cell. So mature RBC actually is enucleated, so it does not have any nuclei. Skeletal muscle cells we know have are multinucleate, and yeah, neurons and zygote. So in a very different way, instead of just asking them how many nuclei are there in an RBC, how many nuclei are there in a skeletal muscle, we're trying to put it in a different format. We're trying to see if students are able to apply their knowledge of number of nuclei, and we look at the data, it's just such close, like 21, 23, 24, 25, 27. They're all so close by. So you see how, and when you get data like this, we can clearly see that students are confused about this. They have not understood this properly. That's why the data is very close, like the numbers are so close by. So, yes, this is a misconception. This is yet another interesting one. Graphical representation of the speed of a car with time, how it's changing. Which segment shows the highest acceleration? So now most students have just directly gone to the the C part, because it's higher up in the graph. It's a little up in the graph. The speed is high. So they are just saying that, okay, because speed is high, this is higher up in the graph, this is going to be high acceleration. And 30% of them have picked that option. um, and they've missed the A over there, right? And it's very small, and it's right in the beginning of the graph. But because it seems like the speed is very less there, they have decided because speed is less, acceleration is low. But that's not how it works. Acceleration is not speed, acceleration is rate of change of that speed, velocity, right? So they have to connect it to time also, that in very less time the speed has increased. So that connection did not happen entirely. So, yes, we've looked at a lot of questions, we've looked at a lot of misconceptions that are there. And what do we do to fix this? That's more important, right? How do we take our learnings back to the class? So, I think Aruna can shed light on this.
Yeah, thank you so much, Purva, for taking us through all of those questions and helping us understand what are, misconceptions that students have with respect to different questions, right? And also, thank you so much for all the resources that you have shared with, and I'm sure teachers will, is very helpful for the teachers, right? Yeah, so we have understood what are misconceptions, how misconceptions occur in science, right? Now, our next step is what? Like, what do we do with all of this information? Yeah, I think straight answer is we will take this back to the classrooms, right? And all of this should go as remediation strategies. But remediation isn't just reteaching the same way, right? There are multiple ways in which we can remediate this. These are some of the ways that we have listed down here, but please feel free to add your own ways of remediation strategies. You can have discussions and reflections, giving a space for the students to actually reflect on these questions will open up a lot of misconceptions. Again, the hypothesis that we have shared is from our lens, right? But when we open that space to students is when we truly understand what students are thinking, right? Another great practice is inquiry based learning, where students explore, question, discover concepts rather than only listening to what we are saying, and this will also help them reconstruct the correct understanding. I cannot agree more about doing metacognition every day with students. Just thinking about and asking this one powerful question of why do you think this answer is correct, or why do you think you have chosen this answer, will actually help them think about their thinking, right? And of course, using a lot of models, analogies, like there's a lot of concepts that are abstract and very difficult for students to imagine and understand. So maybe using some creative models, like something that Purva has also already shared with us, right? Like some models like this, some simulators will help them visualize this and then uncover these misconceptions. And of course, a lot of real world application, because science as a subject is, I mean, that's the boon of science, right? So you can connect a lot of concepts to real life situations, which also strengthen the understanding. This will all tie in together if we have a regular feedback loop with the students. A continuous and specific feedback ensures misconceptions are corrected early and do not become repeated again and again. I think in short, it's just about the right strategies and consistency that will help students to uncover these misconceptions, right? And at EI, we also support schools and teachers with the asset ecosystem. So the three-strand ecosystem for competency-centered school growth is one, the assessment strand, which involves about the diagnostic assessment, surfacing misconceptions, getting specific and actionable feedback, um, identifying gifted students, supporting teachers to make learning insights from the data. The capacity strand actually involves teacher expertise, like the webinars that we are having right now, the misconception series, the learning summits that we have. and the targeted webinars, the misconception mentor program, all of this together, right? And the last one is the learning resource strand, which comes with a lot of things that you already use in classrooms, like the AQAD asset question a day, the teacher sheets that's available in our website, the learning pulse that keeps inquiry alive between formal touch points, right? The newest addition to our asset ecosystem is the skill book. It is carefully designed. Purva, yeah. So this is the skill book, right? And it is very carefully designed workbook that brings teachers and students together to build essential skills through deliberate practice, reflection, and feedback, right? It is very interesting to see how we have designed this asset skill book is on the principle of the gradual release of responsibility, which is I do, we do, and you do approach, right? So you can see the I do place where the teacher actually models out these questions for the students, right? And then we do is where the classroom comes together and solve these questions. It could be students buddy up together, teacher and students together do it in small groups, anywhere, like. And the last part is the you do, where independently students work along and practice these questions, right? This moves learning from observation to actually participation and engagement and independence at the end, which is actually how children learn the best, right? Um, Purva, can you go to the next sheet? We also have launched the Asset Teacher online portal, which is where teachers can actually log in through their unique code and access all the questions, the solutions, and the practice questions at one place, right? And the another thing is about AQAD that I want to reiterate. I'm sure most of you might be already using it in your classroom. So AQAD, I would like to actually pick an example that I recently saw in a school, right? Where in every weekend, the teacher shares a worksheet containing AQAD questions of that week, which students reflect on answer over the weekend, right? And then the next following Monday, students come together in the classroom to discuss their answers. They not only just focus on whether it is right or wrong, how much, questions have I got it, but actually do that metacognition that I shared before, right? So they engage in this deep conversations that actually help them, one, explore these questions. Second is also in an everyday practice, they uncover a lot of these concepts and bust a lot of misconceptions, right? Um, and as part of the learning resource strand, we also have the teacher sheets that's easily available on our website. So you can see we have put a snapshot on this. You can actually go to our website, go to the resources and go to the downloads and get all of these sheets. These are misconception posters that's available for all of us, right? I think that's all from our end. Thank you so much for participating in this webinar. If you have any questions, feel free to drop in the feedback form. Please scan this QR code. It will lead you to feedback form. Feedback is very, very important for us. And if you have also any questions, please put in your questions in the feedback form so that we can get back to you in it. Yeah, have a very, very good evening, and thank you so much.
Teachers, some of you were asking for the samples of the skill book that's been shared on the chat. So please feel free to use that. And for more details about the skill book, you can always reach out to your school's academic consultant. They'll help you out with this.
Please drop in your questions in the Q&A, in the part of the feedback form as well.
If you fill the feedback form, you can feel free to leave the session. And if you have any questions, you can put them on the Q&A section or definitely add it to the feedback form.
Thank you, everybody.
Um, Divya Kanti, ma'am, the skill books are added in the webinar chat. You can see it's there's a sample for grade 7 and grade 5. Uh, okay. Um, Faiz, can you just share the skill books again? Some of them are not able to see it. Hiral ma'am has also said that she is unable to see it. Maybe we can just share it again.
It is in the chat, not in the Q&A section.
Yeah, yeah.
It is shared as two PDFs. Okay.
So Faiz has sent it again. You should be able to see it. Please confirm if you're able to. Yeah, okay. Yeah. In case you're not able to, you can always reach out to your academic consultants. We will
Yeah.
share them with you. All right, teachers, I think thank you for the session. You can, if you fill the feedback form, you can exit the session. We'll reach out to you for any clarifications uh, in that are there in the based on your questions in the feedback form.
Thank you.
Thank you.